Hello again. The other thing I should have mentioned, um, as for things keeping me from doing what I said I was going to do, is a little known thing that I like to call the love of the dengue virus. That is the love of the virus for me. Seems around this time every year. It seems to be breaking out everywhere, and I never seem to be exempt from it. And so that's kept me, well, not being able to think clearly and sleepy and whatnot, and not as motivated. But it should go through its course fairly shortly. Anyway, in this video, what I wanted to go over was something to do with the virtual dub stuff, and that is, I guess it should be indicated in the title, optimizing a video, let's say you've downloaded from the internet for playback on your computer. Now the example I have and that I was going to show you was the one that I actually uploaded for people to download. Conversion of this movie, this older movie, from MKV format to AVI, which makes it more compatible on most DVD players. They'll run Xvid, MP3 AVIs with no problem. The only thing wrong with this file is that it's really got far too much quality, more quality than I would need to watch it with really no noticeable difference on my computer. Now, so what I did was I took a sample of just using virtual dub. Now I can reproduce this in its entirety. These are the frames I just randomly selected a range of frames. Okay. Now, I suppose I could do this over again, but I'll just show you the results of this. Here's a selection of frames, and now you can't really trust this number, because this hasn't been encoded or anything. It's just been clipped out of the original. I don't know how virtual dub comes up with this number, but as you'll see, that's not really the bit rate for this video or this selection of the video. The only way to know what the average bit rate is to go through a full encoding. This hasn't been through a full encoding, so this is some kind of estimate. I'm not sure how it estimates it because it's completely off. Well, it's definitely more than, still higher quality than I would need for playback on my machine. I would like this to run at around, for very high quality, 1500 kilobits per second is a good number to keep in mind. Higher than 1000, somewhere between 1 and 2000 is extreme quality on a regular PC, and good enough even for high definition television with maybe some very little splotchiness. This original is the highest possible quality, But there's really very little difference between these two files, and you'll notice one is half the size of the other. And I'll just show you a bit of this file with no audio. I can. Now I don't know if this content will be content match, so I'll just do a little bit. I don't want to get nailed for content match. Let's see. Now this scene is probably has the most detail in it. So we'll just go back. I'll just run this through at full screen. And now, of course, this is a recording, so you won't be able to tell much, but I'll tell you. Okay, this looks pretty good. I see all the details. I see the little ladder, and that's perfect quality, as expected. Now this here, which is half the size, I'll play as well. I re-encoded this to be about 1500 kilobits per second. I want to go to the same spot. It's around here. Go to full screen. Now this also has less of an impact on my system. It looks fine. You can see all the little details. The ladder is perfectly fine. I can't tell any difference between this and the last one. So, in all honesty, this is taking up twice as much space than it really needs to. Okay. Now, I was trying to download some samples, high definition samples. And I may have got, no. This is Aliens HD TV sample, just a sample, and it's coming in. I can do the same thing with that. But first, how did I do this step? Well, the first thing is the assumption, anyway, is that the bit rate is somehow dependent on the area. Okay. The first thing I want to do, because this is a clip out from another video, is determine what the average bit rate of this bit is. A better approximation than what I've got, in the header. The header, this is informational. It doesn't tell anything to the software that plays this thing. It's just for you to read, right? To really find out, in fact, what it is, you can open up VDub, open up the segment you're interested in, and just try to re-encode it without any changes whatsoever. So here it's on full processing mode, audio, no change, no filters, nothing, and go to compression, select the codec that you would encode with. In this case, has to be XVID. Now, so if you select first off, this has to be unrestricted always, and none of these home, mobile, or anything things. Although those might be good settings. In this case, we don't want to be restricted in any way. Let's see exactly. It doesn't matter for the first pass, but in the second pass, if you want to set the width and height exactly, it has to be set on unrestricted. These are preset widths and heights and data rates, and what we're trying to do is optimize the data rate for our home playback, and essentially, create a profile like one of these things on our own. Now, if I'm using a 2-pass encoding, all right, and I just do that. Just set this like this, first pass and nothing else, and everything here this is unrestricted. You could set things in here, but that's not going to have any effect on this first pass, as you'll see. When I save this, I should also tell you, let's see now, where are those options? This should be checked, discard first pass. So what we're going to be doing is making this tiny little file, and what you do is you do save an AVI file, but it's just a throwaway file. It won't get very big. And all we're interested in finding out is what it computes as the average bit rate. Other options, now I don't know about all of these things. You can try, I have automatic set for that. This thing you want on, okay, because that's going to tell us what it thinks the average is. And let's see, what else is there? I've always set this way. You don't have to have this turbo. I see a little wink and smile, and I think that's probably good. So I keep that on. Now all you do is you just save. Press save and give it a name, any old name, and I call it word. So we're doing nothing. We're just saving. We're doing the first pass. Usually I put this in the system tray. First pass of a 2-pass encoding. And this is in the system tray for me. I can always check what percentage it's at. So what I'll do is I'll pause this, and when that's done, we'll see the result. I'm just jumping in here in the middle. You can see it's about halfway through. If I unclick this so it's visible, you can see what it's currently doing, and what it's currently computing has computed as the average bit rate so far. But it turns out that the tail end of this video has a lot less action than the first part, so this number should go down. We'll see. Okay, it's almost done, and you can see that it's estimated at about 2400. Not completely done. This here is the speed at which it's able to render frames during an actual encoding. So the average bit rate, it says, is about 2400. Okay, not 35 or whatever it says in here. 3589. It's not that. It's more like 2400. Okay, now suppose I'd like this to be around 1500. That's what I wanted to do for this test. As I showed you, these two on my machine, at least from my point of view, look identical. Now, with a way to compute that is simply to, well, I don't know what the formula is exactly, but it's the bit rate you're going to get is approximately going to be proportional to the area of the bit rate that you require is approximately going to be proportional to the area. That is, if I double the area, right? If I double, sorry, if I suppose I increase the dimensions by doubling the x and y, then the area would go up by some factor like 4, go up by the square, and you would expect that you would require 4 times as much data because there are 4 times as many pixels, right? So that's a good first approximation Well, I don't think it's correct, but it's close. So now here I've worked out this out here. It's a 2.35 to 1 video resolution. They call this 720p. I don't know why exactly, but it's high definition. The 1280, I guess. It'll be 1280 by 720 with bars on top and bottom. Okay, so the aspect ratio is 2.35 or 40. If you keep dividing out powers of 2, this works out to 4017, strangely. And so that means that y can be written as x times 17 over 40. And I've called this ratio beta to be cool. Because if you want to be cool, you've got to use Greek letters and make it look like you really know what you're talking about. Next, again, the assumption here is that the data rate is going to be approximately proportional to the area of the frame, the frame size, right? The frame area. And I've given that given the data rate, a symbol, the Greek letter rho, and I'm saying it's approximately proportional to the area, so it's some constant times area is data rate. And I've used mu, another Greek letter, to compound my coolness considerably. Now, in actual fact, the formula for rho is going to be something more like this, because there's always going to be some, at least some constant amount that needs to be, for the image itself. And then as you expand, it's nearly a linear growth in data rate as the area increases, plus this constant, which is probably a negative constant. But at that constant, we're just going to ignore. We'll assume it's 0. You would think it would be 0, because if the area is 0, there should be no data. But I don't think it's a 0 thing. There's always going to be some part that doesn't change with the area. I'm not sure how to compute what that is. You would have to be able to bring it down to 0. Anyway, not important. Okay, so we have initially the area is this, 1280 times 544, and the data rate we just computed was 2401. You can see I've done this already, which is our constant mu times the area which we have. So we have a value for this mu. Just substitute that in there, and what we want is a new data rate, 1500, which is the same constant times a new area, and we just have to compute the new area. Area is x times y, x, why, I should say mu here. I found this dot in my fancy characters thing. Okay, and this is 1500. Right? Now that's mu x times y. I have that twice. And remember that y is beta times x, where beta is 17 over 40. Putting all that in, we get 1500 is equal to this crazy mess, and I worked it out that we have x squared on this side, and we have 1500, and this is on the bottom, times this bit divided by this times this, which turns out to be the square of 1012. And so that's why I re-encoded it at the dimensions 1012, and 1012 times 17 over 40 is nearly 430. Now, it's lucky that these are even numbers. If they're not, you have to fiddle with one or the other until they both come out even. So, like, to do this encoding now, I need to add a rescale, and I wanted 1012. Now, that's okay, right? But if I had this, that won't work. The encoder won't allow an odd number. The X-bit encoder won't allow an odd number here. So I wouldn't want to put 11 here, for instance. If this didn't work, you would just keep trying up and down. This would be no good. This would work because that would be 432 and so on. And then now you don't really need to, whoops. You don't really need to show you the thing here. You don't really need to do the first pass again, but you might as well, just to verify that you're going to get the data rate you expected. I worked that out, and it should come out to about 15. And this is where that funny constant comes in. So let me just show you. I'll overwrite this, doesn't matter. So first pass, I'm going to put this tray, and I'll pause the video again. Okay, it's coming along here, 85%. Now we can have a look at what it's doing. It's currently finding the average around 16 something, which is close. It's almost what we asked for, but a little bit high. And you'll find that it ends up being about 16, about this. So that's maybe 100 over 15 percentages there. 100 over 50. 100 over 1,500, right? Which you could say is this much, and as a percentage, about 6%. We're off by about 6%. And that's why I think that that there's some kind of extra bit that's always there and doesn't depend on the area, and that might just be the actual, the true amount of an amount of data, perhaps for the keyframes, for instance. That could be it, right? At each keyframe, okay, now I got this more HD to try. At each keyframe, however many there are, there has to be, it has to store at least one frame worth of image. Well, then this C here would also depend slightly on A2. So, but it would have to, it wouldn't be as simple a formula as, well, no, it can't be, or else it would just be something times A again, and as you can see, that doesn't work out exactly. It leaves us off by 6%. So I'm not sure exactly what the formula is, but this is close, and for a great big long video. I guess it's done. Now, it hasn't actually done the encoding, it just did the first pass. Right, before this was 60 megs, and now this is just throwaway. But the key is all of the information about the second pass is in here, and it doesn't matter. Now I go to the second pass, which is simply a matter of changing this from 1 to 2. You could try, and I did try putting 1500 in here, but it ignores that. It already knows. It's worked out the average frame rate is going to be by the first pass, and so it really doesn't matter what you put in here for a second pass. That only matters if you're using a single pass encoding. I don't know why this is even available. It's like the keyframes. It ignores what you put in these scenarios, especially for a 2-pass encoding. I could put this up to 2,000, 3,000. It's not going to make any difference. Watch. I'll just put this away. And you'll see, when I come back again, that it's going to have ignored what I just asked for. Okay, back again. I don't know what time it was, but actually, it's nearly there. It's getting there. Yeah, actually, it'll tell us how long it's been doing its thing. Here, nearly 10 minutes. It estimates another minute. But this estimate always goes up as you go along. These two kind of chase each other. Now, this we know is going to come out to 1601, right? I said 3,000. It completely ignored that. I don't know about what these bars mean. It says that I can click this, and I don't know what will happen if I do. I'm not going to. And never have this on auto close, because if you want to refer back to this number, well, actually you don't need to. Look, you just saw. If you're doing a 2-pass thing, this number has already been computed, and it's sitting in here somehow. Let's see now. Now the other two files, they finally came, and I linked them into here. They're MKV files again. Mastroka something or other, right? Now I can convert those to AVI files, but the first thing I want to do is something that I should probably, if there's enough time, well, there's enough time, let's let this finish and verify that it does what we expected. Now, it's pretty close to 1500, it looks like, but it seems to veer off right at the end. I'm not sure why. See, it's going up rapidly, right as, okay. Well, that's what that says, and if you actually look at the file, well, of course, like I said, this is header information. This is less reliable probably than this. It's probably more like 1571. And this, you see, this number could have been computed by taking the physical size of the file and the percentage of it that is video, right? And then divided by the time. Then you could compute this number. But if you're off by 1% here, right? Then that might be enough to bump that number up and down 1,000 or so. for 500,000 in this case. But anyway, in any case, the thing to notice anyway about whether or not this is an optimal solution is the size is about half, right? But the frame width is certainly not half, is it? This is 1280 and this is 1000, so it's 200 less out of 12, which is less than 20% difference in width. You have exactly the same quality, taking up half the space. Now, if this really were, let's take the example of this same video in here. Now, this is a great huge file. This number should be close to accurate, 3272. We go through our same calculation. All we gotta do is change the. We still want 1500, but this here is 3272, right? Everything else is the same. So the answer to make that 1500, what would we need? We need a calculator. 1500 times 1280 times 544 times 40 divided by 3272 times 17. Take the square root. 866. Okay. So in this case, x would be equal to 866, and y would be that times 17 over 40. $368. Okay. Now in that case, it's a smaller frame, which means, we get in order to get a 1500 bit rate, a high quality bit rate, we only, for the video in its entirety, we only need this tiny frame, quite a bit smaller than before. And instead of half, we should be at, less than half the size anyway. If we encoded this full thing, it'll be less than half of this, maybe about 1.6 gigs rather than 3.3 gigs. So we save a lot of space and lose nothing in terms of quality. Now, the last thing, the sample I was going to try and do on the fly here, I can't do right away because I have to convert these to AVIs. But I just want to show you something about NKV. There's a program that I just ran here which allows you to do what needs to be done with these files if you want to convert them to an AVI using any video converter. I put one of these files in here. It's showing that it's got a video part, ABC, blah blah blah, an audio part, and that this here is subtitles. Now these subtitles are going, any video converter for some reason doesn't allow you to, won't ignore the subtitles. But what you can do is demux this thing, see? take the subtitles off, and I want to just demux it. Start muxing. Where to? Oh, I see. Let's put a 1 here. Sounds good to me. Start muxing. Mux. Demux. Mux means multiplex. Demultiplex. See, it's done already. It didn't encode anything. All it did was strip out this text field and give us this one, which is very slightly smaller. That's the one I would want to convert to an AVI. This one won't have any subtitles. If you're on the player, this player and any other player will allow you to not see the subtitles. But when I convert it to an AVI file, unfortunately, this thing will include them, and you can't turn them off. So, but what you can do, actually, I shouldn't delete. Bring that back. Come back here. Okay, well there's the video part, right? We can use the same program to demux the audio and video and leave just the subtitles. Come on, where are you? Probably this one. Yeah, so take this. Okay, it has S for subtitles, I guess. Now it's going to give them in SRT format, I believe. Oh. I thought I fixed that problem. Somehow these dots get my thing next. There. I'll try and fix it. Why is that? I see. What else can I open it with? I lost the regular notepad. Oh, I see. It's all garbage. Wait, is that UTF-8 or something? We'll see if I can have it give me a text file. I know I've gotten it out of, I've done this before, and you can take the text out and it'll give it in, not in that weirdo format, just a regular SRT file. Force track file, language. Okay, here we go. Well, I certainly want UTF-8 if I can choose that. Let's see, UTF 16, no, that's good. I don't know what that means. Let's do it. See what we get. If it is just text, it'll open it. No, it's not. What is it? That's not UTF-8 at all. It's the same as before. I don't know. It's possible. I'll try and figure it out if anyone cares. Okay, well, that's it. Hope you enjoyed that little lesson, and you give it a try. You can save a lot of disk space if you want by doing that. You could also try some of those presets and see if they work. Never worked well for me, but you never know. See ya.